So I'm really excited about this webinar because it really highlights the value that a tool like Blockmason Link has to offer in terms of interoperability. And so last webinar, we went through the steps of deploying a simple ownership contract to the Link private blockchain or network and being able to interact with it with using a basic script. We're going to build off of that, and we are going to deploy a very similar ownership contract, this time using the public GoChain test blockchain. And we are going to add on even further onto that by integrating a payment transfer mechanism using a custom ERC20 token. And that transfer is going to take place using the Ethereum Ropsten blockchain. So this is going to be the first time we do a webinar demo where we're actually working with multiple blockchains. In previous webinars, we've gone through a few slides and a bit of preamble leading up to the demo. We're going to truncate that so that we can spend more time going through the demo itself. But I think it's prudent to go through just a couple of quick slides here. And let's start by asking ourselves, why even use blockchain technology? And before we jump to that, I think as was briefly mentioned, there are a few icons here in the Zoom application that we'd like to try out. So as we proceed and predominantly going through the demo, please sort of indicate whether the pace is appropriate, if we're going too fast or too slow, and we'll do our best to adapt accordingly. So why even use blockchain technology? And these benefits have been brought up many times, but it's important to take a look at this from the perspective of the benefits that, oh wait, let me just move this out of the way. The benefits that blockchain has to offer. And one of the challenges the industry faces is blockchain is seen as a solution effectively looking for a problem to solve. You can almost think of it like a hammer that's looking for a nail to hit. So there are some tangible benefits for using blockchain. The key point here is that blockchain is effectively just another hosted solution, similar to what you might get with a tool like Amazon Web Services, for example. And so by having these hosted solutions, the developer can focus on building things that actually deliver value for their end users. It allows them to focus on their front-end applications and actually building through things that directly impact the end user versus focusing on infrastructure and some of the back-end infrastructure that often takes a lot of time and effort, but may not directly deliver that value.
Yeah, and to chime in a little more on that, blockchain is more than just cryptocurrency and payments. Like, you can think of the payments acceptance and cryptocurrency side of it as more the business reasons why you might want to use it, but we're focusing mainly on the technical reasons here, and of which there are several. And you can see there, like Harris said, you can think of it like a public cloud. It's just a bunch of computers running on the public internet that allows you to deploy applications to it and run those things. So I'm happy to answer more questions about this later if any of you guys are curious about this fundamental question of why even use blockchain. Happy to speak more to that.
Great, thanks, Devin. If any of you have done any DApp development or even used a blockchain DApp, you're probably quite familiar with some of these pain points. And to even just start, the most common requirement for end users and developers alike is that they must go and acquire a crypto like Ether and be able to save that in a browser wallet like MetaMask. So the first task, just going to an exchange, identifying which exchange can be potentially trusted to acquire Ether, and then having to seed that in a browser wallet and get that set up. From a developer's perspective, they need to install large complex libraries like Web3, set up dependencies on the browser wallets. So all these steps add friction to the interaction between the app that the developer is trying to create and the end user. And so just taking a look at this example here on the screen, you can see all the different steps required, which just add a lot of pain points for both developers and end users. And we can see that with a very simple example, something that we've covered in previous webinars. If I want to use a basic DApp, let's say my Crypto Heroes, which is one of the top trending applications on the Ethereum blockchain, and I try to interact with this particular app, the first thing I will be required to do when this app loads is to log in with my MetaMask. And I don't know what this app is requesting from MetaMask. I don't know what kind of access they're going to be requesting, what kind of information they're going to be able to access. But this is just like the first step in this app and user interaction that, as an end user, has got me a bit startled, because they are asking for access to something that may contain some digital assets. And so that's not necessarily a type of experience that we want to be experiencing when we go through and work with these dApps.
Yeah, it's like walking into a convenience store, and before they let you in the door, they ask you to give them your wallet.
That's a great example, Devin. Thanks. So how can we address some of those friction points that were mentioned? Well, Link is one of these tools that we believe will address those pain points. And Link at a high level is essentially just a managed, decentralized functions as a service platform that is really pushing the envelope of interoperability. And at the core, Link brings the convenience and familiarity of conventional web APIs to developers without necessarily having that vendor lock-in that you might get in with other functions as a service products like AWS Lambda or Google Compute Engine. And so the goal of Link here is really to empower developers to focus on the more creative, the more innovative projects, and help them get their ideas to market rapidly. And with Link, we believe that we're able to get the users and the developers of decentralized applications to expand beyond the pool of early adopters and really try to make the incorporation of decentralized distributed ledger technology more mainstream.
Yeah, and TLDR that we're trying to help blockchain get out of the way so that you can just write code and get people using that as quickly as possible. And as we saw from that earlier slide, there's all this complexity. There are all these steps between you and getting something done. And so we're just trying to alleviate as many of those steps as possible to help you focus on the value. What is it you're trying to build?
So we've talked a little bit about what Link is. Let's take a quick look at why use Link. And a lot of these points have been mentioned either through a few of the slides before, or the points that Devin has mentioned here. Essentially, you get this hosted solution where you don't need to spend time managing backend infrastructure. You can focus on delivering the end value to users. You can basically use conventional APIs in your front-end applications instead of having to use some of these more blockchain-specific complex libraries like Web3.js. And since you're just using conventional APIs, you can code in your preferred language. Link provides a host of SDKs. So if you want to program with JavaScript, if you want to use Java or .NET, we've actually got SDKs set up in those languages, along with building more of them, so that it's easy to make use of Link. There's also a managed Ethereum account that's hosted by Link. So that takes care of essentially non-payable or sort of critical financial transactions, so that you minimize this end user friction between the app and the end user. And what all this leads to is ultimately the goal of interoperability. With Link, you have the ability to use multiple blockchains in a single decentralized app. And you can effectively pick and choose the blockchain features that you want to incorporate. And we're going to see this in the demo in just a second here. But you can pick and choose the features the blockchain features that you want to incorporate, as opposed to having be forced into a single stack or using a single blockchain network. And so we'll get into a really cool example with that in just a second. Some of the supported programmable blockchains to highlight. So in the past webinar, we talked a little bit about the Link private network and deploying to that. We also support Ethereum. GoChain was recently announced, and these are a few other programmable blockchain that we're looking to support in the future as part of our roadmap. Okay, let's get into the meat of the webinar here, which is our demo. And if any of you online here want to follow along, we do have this repo that's publicly available on GitHub, which you can clone, download onto your local machine, and actually run the front end app that we're going to be demoing here for you. And so feel free to go ahead and clone and download this. There are going to be a couple steps in the demo that has either been covered or will require you to, for example, go to the GoChain Telegram community to acquire some test go. So there will be some points here that we're going to move through relatively quickly because it's something we've already done that might take a little bit of time on your end to actually do. Okay, so the first thing I just point out here again is the Link website where you can get started. You have the ability to see the tutorials, some of the past tutorials that we've done. And once you set up your Link account and your organization, you'll basically see an interface that looks like this. And this here is the Link IDE or integrated development environment. It allows you to quickly write up code. And as we saw in the previous webinar, the code that's written up here gets deployed almost immediately to the Link private network. And so you've got this toggle here where you can see the corresponding API that's generated with the code that's written up here. And so, again, we went through this in the last webinar. What we're going to do in today's webinar is walk through the steps of deploying an ownership contract to a public blockchain like GoChain. And that one's a little bit more involved. And so what I'll do here is quickly show you what the flow looks like. So you have a high level image of the process, and then we'll actually go through and run through the steps to create the GoChain APIs. And maybe just before we do that, let me show you what the front end app that we're going to be working with here looks like. And again, the front end application is provided in this GitHub repo. I'm going to open this up in my Visual Studio code editor here. And I'm just going to run it from here. It's just a little bit easier to see. This front-end application uses Parcel, and so it just makes it really easy to have your web hosting done using a tool like Parcel. So I'm just going to run the index.html. We're going to do this over HTTPS. And let's see what the front end looks like here. So by default, Parcel runs your web application on port 1234. So what we're going to have here is just a collectible digital paintings highlighting a few wonders of the modern world. So this is the application that we're going to be building out here, and having the ownership of the digital painting recorded on the GoChain testnet. So let's get started in Link here. And what we're going to do is we're actually going to deploy our ownership contract, again, to the GoChain testnet. And so we've got the contracts folder and the ownership folder, and this should look familiar if you had attended our previous webinar. It's a very simple contract where we've got a mapping between a string, which is going to represent any sort of asset, and an address, which represents the owner of that particular asset. So I'm just going to copy this this contract here, and let's go back into Link. And what we're going to do is we're going to, and again, what we're doing here is copy and pasting a contract code in the Link IDE. What happens when we paste a contract code here is that it gets deployed to the Link private network. And again, this is what we had done in the previous webinar. I'll just take a second to update here, but you'll see the endpoints generated for this particular contract. And because we're doing this on the Link private network, this is done automatically. There's no need to go to an exchange and acquire any crypto that you need to pay for the gas fees. This is all sort of done here behind the scenes. Let me just make sure this is there we go. So we've got our set owner, our owner of, and our authority. So that was pretty easy. But again, this is being done on the Link private network. If we want to deploy this on a public blockchain, this is the high level flow that we're going to have to follow. It looks something like this. So we've got our application Link. We write up our smart contracts using the tools in Link itself. And as we've done, we've deployed it to the Link private network, which comes by default as part of the Link application. But if we wanted to use a public blockchain, we would need to specify the name of the blockchain that we want to use. So for example, Ethereum or GoChain, we need to identify the network. Then we need to actually connect to that network. And with the likes of the Link private network, where this is done automatically, there is generally what's called a JSON RPC API that's used to connect to these public blockchains. And I'll show you what that looks like in just a second. When we connect to the Ethereum network, we actually use a third-party API called Infura, which allows us to effectively connect to Ethereum without having to run our own nodes. So it's just a third-party service allowing us to connect to that network. If I'm going to connect to GoChain, if you take a look at GoChain's get started documentation, it talks about being able to acquire some test Go from their Telegram group, which you'll need to seed the wallet. But there's also the documentation which highlights what URLs to use to connect to the network. And there's one here for the testnet, and there's one here for the mainnet. So we're going to use this URL to connect within Link to the GoChain testnet. All right. So in order to go through that process, we'll start and we'll create a new project. And we're going to create a new contract. This is going to be our ownership contract. And let me just copy and paste the contents of that code here. So that's the first step. When we go through here, we're basically writing up our contract. So let's save that. So we're going to use the ownership contract. We're going to use the default Ethereum account that's provided to us and hosted by the Link application. And now we're going to specify a new network. And this one's going to be the GoChain testnet. We'll use the defaults here. We don't need to modify any of these other settings. And the connector we're going to use, again, is the URL that we saw here, this network RPC URL. So that's going to go here. Oh, let me just copy and paste this again. And we're going to call this ownership GoChain. Let's call this connector. And the network that this is going to be connecting to is the label that we provided here, the GoChain testnet. So let's save that. Where's your contract deployed? So with Link, you can pull in an existing contract that's been deployed if you know the address of it. In this case here, we don't have an existing contract deployment. So we're going to call this ownership GoChain testnet deployment. The account associated with this deployment is the default account. That's the contract that we want to deploy, and that's the network that we want to deploy to. So Link's going to ask us if we're ready to perform the deployment, and depending on how the performance of the blockchain itself, it could take up to a minute or two. With respect to GoChain does have is defined to have pretty well performed performance metrics. So this should actually happen relatively quickly. But while that's deploying, let's just go back here and talk through the rest of the flow. So what we've done is we've set up our connector. We're now deploying our smart contract to the respective network. We'll then label our API in Link. We'll then label our API consumer. So this is the actual front-end application that is going to be accessing the API in Link. And all of this is managed just through an OAuth setup. So there's a client ID and a client secret that's going to be used with OAuth, which is going to provide an access token. And that's the token that's used when we're making our API requests to the Link API engine. So the overall flow looks something like this. We make a request from our front end with the access token to the APIs, which then gets routed to the corresponding network through these network connectors. So that's what we're trying to accomplish here with the setup in Link itself. Okay, so we're at the stage here where we're just going to label our API. So in this case here, it's going to be ownership GoChain API. The contract's deployed on the GoChain testnet. So let's save this. That's the API we're going to use. We're also now going to create our consumer. And so in this case here, it's some sort of collectible asset, collectible painting. So that's going to be the name of our API consumer. That's our API. That's the account. So again, this is the account that basically facilitates the transactions that take place to use this API. Let's save that. We get a client secret automatically generated for us. So we just need to hit save. And when we hit finish, these are now our ownership contract APIs for accessing the contract on GoChain. And under authentication, we actually have our client ID and client secret that we're going to use with our Blockmason Link SDK, our JavaScript SDK, to be able to quickly and easily use these API endpoints. So just to summarize, I know there was quite a few steps that we walked through here, but we basically went through the process where we deployed our smart contracts to the GoChain network. We had set up our connector. We had written up our smart contract code in Link, deployed it, and then we set up our API consumer, the front end that's actually going to be using the API, and making sure that we've got the appropriate access token to be able to do so. So that's what we've gone through here. Now, back on our front end, let's just take a quick look through what we need to do in our application here. So this is the front end. It's just loading a bunch of stamps, and this will all be from a file called stamps.json, and the script file here that it refers to is this app complete. And so the app complete pulls in the Link SDK and passes in the client ID and client secret. So this is where we're going to copy and paste the client ID and client secret that we obtained here from in Link, and this will then allow us to use these API endpoints. So the rest of the app is fairly straightforward here in terms of basically just presenting all the stamps and then marking any ownership of the particular, in this case, it's actually the painting, sorry. And we're also able to set ownership by passing in an address for who's going to own that particular digital painting. So let's try this. We're going to go back to our Link API documentation. Let's copy the client ID. And again, just to point out here, and I'm sure Devin's got some comments about this. I mean, obviously, best practices is not to have your authorization credentials in the front end. This is primarily being done for demonstration purposes.
Wait, there we go. Can you hear me now?
Yep.
Okay, sweet. Sorry, I was talking into a muted phone. Yeah, the only thing I would really say about this right now is that you know, to echo your sentiment, Harish, that you probably in a real world application do not want to embed this client ID and secret directly in the front end. You would want to protect this somehow, and I'm happy to talk through techniques or field questions about that later on.
Okay, so let's just run this application again. We've specified our client ID and client secret from Link, and so it's built. Let's go to our application here, and so we see. Oh, all right. Here we got our collectible digital paintings of the 7 wonders of the modern world. This button here that allows us to own the asset. And we see here something related to the price of the painting, but we're actually not going to touch that part. That's going to come in the second step here when we look at the payment mechanism. So we just need to enter in an ownership address. And in theory, what should happen is we see that particular address become the owner, and we can actually verify that this is recorded on the GoChain blockchain by going to the GoChain testnet explorer, which allows us to search by the transaction address or block. So let's just take a look and see that this happens as expected. So I'm just going to copy and paste an Ethereum-based address, which should look familiar to most of you. And let's see, let's try to own this. So again, it's being recorded on the GoChain network, and there we go. So we see that the owner has been set as that address. It's recorded here in the footer of this painting. But let's actually verify that this got recorded on the GoChain, the blockchain. And the way we can do that is if we go back into Link, and we see that, you know, here's our API documentation. Let's take a look at this Ethereum contracts deployment icon here, which tells us where the address of the deployment itself. And we see here the ownership GoChain testnet deployment. That contract was deployed at this address here. So I'm just going to copy this address. Let's go to our Blockchain Explorer, and let's paste that in here. And voila, there you go. So there's our transaction hash. This was the creation. This was the transaction of us just recording this address as the owner of this particular asset. So what we've done is we've taken a very simple, very basic front-end application of some collectible digital assets, paintings, and we've plugged in a blockchain using Link, and we're now able to record the ownership of these assets on the GoChain testnet. And if we were to just go through that process and use the GoChain mainnet JSON RPC, this here, then we would be able to do exactly the same thing, except this time we'd be doing this on the mainnet. Great. So let's take a look at what if we want to add in a payment layer to be able to acquire these digital assets. Right now we're just setting the owner, which is fine for a quick demo, but let's try to make this a little bit more real, where in order to acquire this digital painting, you have to pay based on what's presented here. So in one of our popular tutorials that we have, create your own ERC20 token, we went through this process where on the Ethereum Ropsten network, we were able to create our own custom token. We're not going to go through those steps today. You can definitely go to this blog and go through it at your own pace. But what we've done is effectively gone through this blog post here and created a set of APIs for a custom token, and we've called it the OWN, or own token. I know it's not the most creative name here, but it's a very simple token. And if we take a look at the documentation here, these are all the API endpoints that are available for this particular own token contract. You can get things like the name, the total supply, which is expected, but you can also post to transfer tokens from one account to another. And so that's effectively what we're doing with our Link application. In order to acquire one of these paintings, we will be transferring our own custom OWN token from one account to another. So if we go back to our code base here, there is this file called app complete multi-chain. And so this is the one where we actually have baked in the payment transfer mechanism. And so what you see here, very similar to what we were doing before, we're pulling in the Blockmason Link SDK, and we've got our ownership project. And again, this was to assign the ownership of an asset on the GoChain blockchain. And we just need to put in the same client ID and client secret that we had here. So I'm just going to copy and paste that. So up till now, this is exactly the same. These are the credentials that allow us to use the GoChain specific APIs. But what we have here under payment project are going to be a set of credentials that allow us to work with this set of APIs. These are APIs for the own token contract, which is on the Ethereum Ropsten network. And so take a looking at the authentication. Let's take our client ID. We'll paste that in here. And let's take our client secret, and we'll paste that in here. And so all we're doing here is having the ability to actually transfer payment from the party that owns an asset to the one requesting ownership of the asset. And this is all being done using the custom ERC20 token that we've created called OWN. All right, so let's save this. And if we go back to our index.html, let's just make sure we're pulling in the right script file. So this is the multi-chain. We'll save that. And now if I go back to my application, Just refresh that just to make sure. So now it tells me that each of these are worth a certain number of OWN tokens that I would need to pay in order to be able to own it. So for this part here, I'm just going to use MetaMax because I just want to be able to pull in a few addresses and actually ensure that the owner is getting paid the number of tokens that's expected here. So let me just bring this up. I don't want my crypto heroes. And so this is the account one that currently owns this particular painting. And if I take a look at the number of owned tokens this account has got, 188,005. So if I am to, if I take another account here, let's take account 2 and copy that. And if I want to set the ownership of this digital painting to this address now, I will have to pay the existing owner 5 OWN tokens. And so what that means is that I should see the total amount of OWN tokens for account 1 increase by 5 as I basically pay to own that painting. So let's see if this actually works as expected. So that's going to be the owner. And again, because this is being processed with the Ethereum Ropsten network, we'd expect that this one takes a little bit more time than what we saw with the Go chain transaction. And in sort of thinking through again, as we're using 2 different blockchains here, we're basically looking at recording the ownership of the asset on the Go chain blockchain. And we might want to do that because let's say a user here is going to buy 100 different digital assets. If they are processing each one and recording it on, let's say, the Ethereum blockchain, that'll take a lot of time. It'll cost a fair amount in transaction fees. It might not be the most effective way to record an ownership of, let's say, 100 different assets. Whereas with GoChain, it's much faster. The transaction costs are a fraction of what you would see on the Ethereum network. And so we might choose that we want to record ownership on GoChain, but maybe the payment layer we want to keep on Ethereum because it's a bit more transparent. There are more, better Explorer tools for us to be able to see the payments take place, plus the nice tie-in with MetaMax to be able to see this in your wallet. So you may have noticed that the owner updated here. So this is the new owner. And let's see if account 1 here actually increased. So it did. So account 1 now has another 5 tokens that they've acquired because they basically sold this painting to this new owner. And so what we've done now is we have taken the payment layer, used the Ropsten network to be able to record payments made for digital assets, but the actual asset itself is being recorded on the GoChain testnet. And we can just quickly verify that by going back to our testnet explorer on GoChain, refresh this, and we should see another transaction hash here as it was just recorded on the GoChain network. And so I mean, this is pretty cool. We're using multiple chains here, and we're going to just take this one quick step further where if you take a look at it from the perspective of the end user, this concept of an own crypto token may not be very intuitive, especially compared to what they might be used to seeing with an e-commerce platform. And so we can quickly change that. If we go back to our code, we'll go to our front end. Instead of having this some sort of custom ERC20 token, let's just call this USD for US dollars. And what we can do in our app here is create this sort of conversion rate. So let's say, 5 owned tokens, or one owned token is equal to 5 USD. And so now if I save that and we go back to our front end, we see that the interface now is a lot more intuitive. It looks and feels like any other e-commerce website. I'm seeing things in a currency I understand. but behind the scenes, it's being converted into a custom crypto that we created, the OWN token, and that's being transferred for payment. But again, that complexity is not really a concern for the end user. They're just looking at this and saying, "Oh, great, okay, I can, buy this in a currency and a number I understand." And so that's sort of the power of using a tool like Link, where Link can abstract away that complexity and allow the experience for the end user to feel as natural as it would with any other e-commerce site. So I'm just going to stop there. I think, I mean, we've obviously covered a lot here, and I fully expect there, to be a bit of time required for folks to have digested all that. So again, this demo will be recorded, and feel free to go through it a little bit more at a comfortable pace, or play it a few more times. But I'll park it there, and let's open it up for any questions.